My name is Jeroen. I work at Microsoft as a technical evangelist, or whatever they call me these days, on data and AI, and would like to tell you a little bit about what happened in the AI space and the ML space. So basically what I will be doing, I'll be revisiting what has been announced on Ignite, on AI and ML, on Azure, the changes we have announced there, and the new products we launched. And if everything goes okay, I'll be doing a live demo of that new stuff, which is really interesting. It took me a long time to get it working, so let's hope it will still be working when we get there. So that's the plan for today. So let's see. So first of all, what do we see when we look at the AI and data science space? We see a lot of challenges, and we see a lot of developments as well. So we see that more developers are using artificial intelligence. We're seeing scenarios where people want to do training in the cloud and then maybe scoring on a small device. So you have a lot of data that you analyze, and you have a predictive model based on that you train in the cloud, and then you want to have only the outcome of the model, and that scoring of actually doing a prediction, for example, on a very small chip, or maybe a Raspberry Pi or something like that. That's kind of the scenarios we see. So the AI world has been growing, it has been changing rapidly over the last couple of years, and there's still some challenges there. One of the biggest one is data prep. We see that data scientists are spending 85% of their time wrangling data. That needs to improve. That's what we think, at least. So we need to help them out to change the data prep workflow. It's still hard to do model deployment and management. Of course, with Azure ML Studio, we tried to change that a little, but yeah, that's still a challenge for us. Model lineage and auditing, and the explainability of AI is, of course, a big topic that has been discussed already multiple times in the news and in the media as well. I'm not saying we're going to solve all those challenges today, but at least that's what we think is going on, the key trends and challenges, and why we invested in doing Azure ML and doing the AI space in Azure a little bit different. So what I'm talking about, well, when we do AI development, we have data on the left side. We do ingestion, storage, preferably in Azure, and then we do preparation and training of the data. So we have data stored in a data lake, for example. We train it, and then we model something on it to predict, for example, customer churn, or temperatures, or stock prices, or house prices, what have you. And then that needs to be included into an app and to actually convert it into insights for your end users. Where Azure Machine Learning sits is in these last two steps. Right? So a lot of Azure does already ingest and store. That's perfect, that's there. And then what can we improve on Azure Machine Learning for the last two steps to prepare your data, train the data, score it, and serve it to your applications. So what is new and why? So what did we have? Well, we had Azure ML Studio. Who has played with that? Anyone? How was the experience? Good? Bad? Yeah, that's essentially what we got back from our customers as well, like, meh. It was good. It was really useful to have a visual flow of your data, to see, okay, data is coming in at the top, I'm doing a split, I'm doing data wrangling, I'm training this and this model, this is the result, etc., etc. It's really nice. I like the visual interface. Problem is that it was less extensible. So people wanted more control over where the data is stored and where the compute, the training of the model, and the scoring of model is done. Where you deploy the model, either on premises or in the cloud, in Docker maybe, or in a VM you wrote your own. There was no way to control that. I mean, if you used Azure ML, you would be using our platform and our machines. You would never even see them. You didn't know what size they were or what software they would run. And then also people wanted more frameworks, all of them. We only offered a couple, and then we said, that's it. So basically what we heard from the feedback on Azure ML Studio is that people need more flexibility on frameworks, on deployment models, on where the data lives and how it is computed. People wanted more flexibility. So with that in mind, we started changing. And the key goals for our preview here is to help you build, deploy, and manage models at scales in different environments, and try to give you the flexibility while still having this managed feeling. And it's up to you to decide if we manage to achieve that. Okay, so Azure ML Studio, it will still be there. The services are now called Azure ML, and there's multiple subparts in there. I'll have a slide on how it all fits together. But the Studio will still be there for the graphical interface, and then we'll have other tools for the more customization interface, and probably the workbench for the data scientist will shift from the visual interface Azure ML Studio to something else that I'll hopefully show. So what did we announce? We announced the Azure Machine Learning Services, which is your experimentation and models management service. So anything you do with any IDA or a notebook or our new tool, Azure Machine Learning Workbench, or the Visual Studio code tools for AI, anything you do there, you can use any of those IDEs, even IDEs that we don't own or offer, and you can use that to build and deploy models on that service. And then you have a choice where you want to deploy it. You can do it on Azure. There's multiple choices here, for example, virtual machines or SQL Server. You can go on premises to your own container services or SQL Server or a machine learning server, or if you want to go to the Edge cloud, you can go to Azure IoT Edge. So the idea is multiple IDEs, you choose your own IDE where you want to work, and then this service will allow you to deploy it in many different flavors, both in the cloud, the Edge, or on-premise. Okay, so how do I get this? How do I get this new capability? Well, it's really easy. You go to New in the portal, AI plus Cognitive Services, and then you click Create. That's it. You fill out a form, you give it a name, and you click Create again, and you wait a little, and then you're done. And then you have your machine learning environment. And then you need to install some tools. So what did you then get? What did you get that's set up now, and what tools do we now offer? So there's two things: experimentation account and a model management account. Experimentation account is where you spend most of your time if you're a data scientist. That's where you run against and run your training and model implementations. So you will start with some data set, do some data wrangling, have a first training, reiterate again and again and again. That's all happening against the experimentation account. That can run locally or in Azure in a scale-up or scale-out fashion. And anything you do, both local as well as in the cloud, is tracked through that experimentation account. So anyone running on that experimentation account, regardless of how they do their work, it will all be tracked and visible in that one overview. We'll see that in a sec. The model management account is for the next step. Once you have a model deployed in production, for example, against your CRM or against your website, you want to be able to easily scale that up and down and move it maybe from Docker to VM or to on-prem to Azure and change the code base easily and make a very simple update. That's where the model management account is for. In my demo, I will not be showing that. Why? Because it doesn't work. It's not there. I tried yesterday night. I even got a not implemented exception on a function, which, if you know a little bit about programming, is what happens if you have just a stop method and nothing implemented yet. So this is the plan. It's not there yet, the last part, unfortunately. So let's look at the experimentation service. Again, any IDE, you talk to the Azure ML experimentation service, and then you choose where you want to deploy your model, where you want to run your training and your scoring experiments. So they can run on a local machine to a data science VM, Spark on HDN side, ML server, which is the Microsoft ML server, and then something new which we call Azure Batch AI, which is coming soon. So as you can imagine, that's also not there yet. What can you do then? Well, you can work with any framework or library. We support CNTK, Spark ML, and TensorFlow out of the box, but it's very easy to add more. It's open framework. You can use any tool you would like: Visual Studio Code, our Workbench, normal Visual Studio, Jupyter Notebooks, PyCharm, and then use Docker and Python and R and Git and all the others you would like to use. So it's flexibility of choice, whatever floats your boat, what framework you like to use, what language you like to use, what IDE you like to use, you can always work with our experimentation service. So this is where you spend most of your time as a data scientist, doing that work. Training, scoring, wrangling, etc. Once you're done, you should be able to publish it to the model management service, which means publishing from our workbench or whatever tool you chose to a Docker environment that can run basically anywhere. Might be SQL Server, might be Microsoft ML service, might be Azure Container Services, or what have you. Again, that part, still up in the cloud to see how that will land. So to enable you to actually do some work here, we also included Visual Studio Code tools for AI, which you can use to do your whole data science work if you want in this Visual Studio environment, if that's what you're looking for. So if you're used to that, you like that, the add-in is there. It integrates also with another tool which we call the Workbench, which will be a major part of my demo. The Workbench. The Workbench is the coolest tool here. It's a data science workbench working on, it works on Windows and Mac. It's a full setup, full contained, so you just download the installer and we install Jupyter and Python and all the packages that we need. So you don't need to worry about configuring and updating those as well. That's our job. You just update the tool and then the packages will be updated. Notebooks, Jupyter notebooks, are embedded in this tool. So if you have notebooks, you can easily import them and run them here. And then the runs, the assignments, what you do, is always tracked on the Azure ML Experimentation Service. So that's how we can switch from IDE to IDE. And what I really like about this is that we introduce new data wrangling tools. So who knows about Power Query from the Power BI side? You will see stuff like that in here. So we listened to what we did there to easily change data types, to split columns, to do other stuff. And then parts of that is slowly making its way into the workbench to allow for easier data wrangling without having to write all that code all the time. Easier data wrangling, applying of functions to a data set visually. So that's something that is, I think is very cool. Talking about it, that's the AI-powered data wrangling. This is a screenshot. You'll see training data in a data set. You can change column names and things like that. You can see, for example, the top 6 values, a scatter plot of the data, box plots of columns. So it's very easy to understand what's going on and clean your data. As I said, it looks a little bit like Power BI because it has the queries, or what we call data flows, here on the left, then the data set here with the inspectors, and on the right are all the steps that you applied. Much like what you see in Power BI and Power Query window. Okay, demo time. But what day is it today? It's Friday the 13th. That's looking for trouble. So before we do the demo, let's first focus a little and maybe offer and appease the demo gods, please. So let's, fingers crossed, let's see if this will work. Don't shoot me if it doesn't. We'll be looking at the workbench. Okay, so here we go. The workbench. Well, that part worked. Good. No, this is this will still work. At least the first couple of clicks will be fine, and then we'll see what happens. This is what you will see when you start up the workbench. The idea is that you have projects in a workspace. Make no mistake, that workspace is already defined on Azure. So it needs to know where that workspace is on Azure. So anything you do, even if you create a new project with data files and you don't run any training, that already will be tracked on Azure, that you did that. So we'll just create a new project. I'll call it, I'll be doing the canonical version of ML because it's not really about the machine learning, right? It's about how the tool works. So we'll be doing the classic example of classifying irises. I would assume most of you know that data set, right? A number of features on the flowers, and then we say, hey, this is this type of iris and that type of iris, basically. Multi-class classification. So the ML itself will not be very interesting, but it's about the workflow, the way you work with the tool. So I'll just use that template, create. So we'll see a sort of introduction, how you can work with this example. This is, by the way, in a Jupyter notebook already, so that's integrated. And we can start understanding what's going on. There's two ways of doing that. You can either go here and explore the tools and the scripts that are in this model, or it's better maybe to open this project in Visual Studio Code. So if you have Visual Studio Code installed and the AI tools, this integration will be there, and you can easily switch from the one to the other. So if you like the code visualization here and have the Python tools installed, you get a nice auto-formatting and autocomplete and things like that in here, which is not in the workbench. And you can also kick off tasks from here into the workbench by using the right-click menu to submit a job into Azure ML. So there's a two-way integration between these two tools. So let's have a look. This is the data set, the Iris ISV. There's nothing much about it. It's 5 columns. The first 4 are the features, and then the 5th one is the predicted, the actual type, species of iris. So that's what we will be predicting. So let's go back to the workbench. Let's have a look at the data sets. So we have data sources and data preparation. So you can have one source and have that prepared in multiple ways. So I'll just add a new source. I can choose where I want to load the data from: files, Parquet, Excel, database. Well, for this it's just a CSV. I'll browse to the CSV. And then hopefully we'll figure something out about what the CSV, how the CSV is formatted. You can change this, of course. It has detected the right stuff, like don't skip header lines, UTF-8 encoding, comma separation, so that's fine. And then we'll also try to figure out the data types. For some reason it doesn't really work with CSVs with numerical values in there. As you can see, column 1 to 4, I don't know why, but hey, it didn't work. So I'll quickly just change that to numeric. Next. Then I can optionally choose to do a data sampling. So if you have billions and billions of rows and you only would like to have 50,000 sampled randomly from your data set to have a easy to work with set, you can do it here. And finish. And then my new data source should be done. Let's open it. We'll see the source. And I can get some metrics about the source to see the distribution of my columns. This is very much like what you had in Azure ML Studio, right? If you open the data set, you can easily see the metrics, distributions, minimum value, maximum value, counts, quartiles, etc. And there's a lot of cool metrics that you can calculate about this. One that catches my eye is the number of missing values. There's definitely something I need to do before to be able to run this experiment. And you can see the most common species. There's a lot of metrics that we calculate. You can also choose which metrics you want or do not want to see. And then going back to the data, if you want to wrangle it, so you want to change this, you click here to prepare. And you will have to create a data prep package. And this is the Power Query window, maybe, so to speak. I can rename columns here, so I can say, hey, this is the sepal length, and the sepal width, petal length, petal width, and the species. So all the things that I do here are tracked on the right side in a little program. There's also a way for you to go into the code and build it yourself. It's all written in Python, by the way. So all these steps are just done in Python. If you click on any column, you can also hover over them. You see that there's 150 valid items, 1 missing, 0 errors. So there's no strings in here. It's just one row that is empty. Let's get rid of that. And I can do that, for example, by going here to value counts and asking the tool to show me how much each species appears. And then we see one row with no species, so that's probably the empty row. I can click on it and then remove it from the from the set by clicking here on this little minus sign, filter out, and then you will see that the null is gone, and then the filter is in my steps as well. So this is basic data wrangling you can do here. There's a lot of stuff. You can do transforms, you can expand JSONs, you can replace values, trim strings, you can run your own scripts if you want to, using Python as I already mentioned. So there's a lot of stuff you can do, sorting, summarizing, removing duplicates. Yeah, I have not seen anything yet that I'm missing, but hey, that might be just me. So very powerful. So once you're done here, you'll just close this preparation screen, and then you pray to the demo gods a little, because this sometimes breaks. Just closing this window. Good. Phew, lucky. Okay. So now we have the data prepared. If you now want to run code against it, you can click here and say generate data access code file, and we'll create a very simple Python script for you to be able to talk to the package to the data prep file you just created. Interesting here is that we have a Azure ML logger, and the Azure ML logger is how this Python environment will talk to the Azure ML environment to tell you what is going on, and also tell you about results and how long it took to run and the accuracy and the recall of your model. So this is very important to include. We'll disregard this for now because we built our own code as well. Okay, so let's go into Visual Studio Code again, and let's open up the Python script. As I mentioned already, here's the logging to be able to log against Azure ML, and we'll print some information, we'll test the data, and then you can also pass parameters to this Python script through the Azure ML workbench. So here's an example that... Yeah, I can try. Iets ouder dan 25. Let's see if I can. There we go. Whoa. Good enough? Okay, thanks. Thank you, Sander. So regularization parameters 0.01 standard. If you pass in anything through the workbench, you'll see that as well. So you can pass in parameters. It makes it very easy, for example, to run multiple parameter settings on the same model, just using one call. So that's the script you will be working on. You know, we'll just log some stuff, do the predictions. You know, not very interesting in the sense what it does. If I want to run this, I can do here, click here to AI submit job. I will not do that, or maybe I'll do. Yeah, I'll just do it. And then I can tell it where I want it to run. So by default, it can run on Docker and local. Local means just local Python interpreter. Docker means Docker environment locally. So if I type local here, enter, this will start. Good. So this will run. If I now go back into the workbench, I can see the runs on this project, hopefully. And this should show up any second now. There we go. Ignore this one. This is still running from 3 hours ago. Don't care. But the top one is now running, and I can see how many runs I did, how many were preparing, running, completed, failed. And then also, because we output the accuracy regularization rate using the logger, this workbench automatically creates graphs on top of that to see, you know, if something is running and when it completed, how. So normally, this should be done, like any second now. So let me, there we go, phew. So the run has been completed, 36 seconds, and I can click on the run and see, you know, what was the output. We'll see all technical logs, but also graphs on the accuracy and versioning, if, the recall, precision, thresholds, and then some visualizations that we may have generated in the code. So this is interesting because if you just output something to a file, we'll know, and we'll dynamically create this page, so anything you output to a file, like an image, is shown here. So you don't need to specify that. Anything you write to an image, we'll pick that up and show that as an easy to understand page. Okay, let's go back to the run list. I can do this again by going here to local, I can change the environment here as well. Local, I can choose the script that I want to run, and I can pass in the arguments. So I think I started with a regularization rate of 0. So let's go with 1 for now, run. And then another one is ran locally, submitting, should be done in 30 seconds. If I'm really feeling lucky, I can change that to Docker Python and give it a regularization rate of, let's say, 1.5 and run it as well. This should probably take a little longer because it's spinning up Docker as well as a comparison to just running locally. Okay, done. So as you can see, it doesn't really matter what environment you run in. We can always track this and see what's going on, and multiple tries of running the same model in various environments or various settings can be easily tracked that way. We also have the Docker Spark integration, so if you're running a Spark script, you can do that as well, just to change to see if that engine would work better for you than the normal Python environment. So if you want to run Spark, that's there as well. So you can see duration, regularization rate, accuracy dropping. It's not really improving. My first try was better. Right, you see accuracy of, let's say, 68%, something like that, of try number 1. So with a regularization rate of 0. Oh, there we go. So the last one with PySpark with a regularization rate of 1.5 improved a lot in accuracy terms. Maybe a little bit too much. It's almost at 1. So that might be something else going on there. If I want to compare runs, I can do that as well. I can click 2 runs and see how do they compare, when did they start, what was the environment used, what script ran, what was the duration, and also any output that those items, those runs did. You can see them side by side. So it's easy to compare 2 or more models side by side. This is a very big improvement for us because in Azure ML Studio, if you ever played with that, there was no way to compare more than 2 models side by side. You only had the option to do 2. Which made me cry a little because I feel I need more options. But talking to the product team, they said, why would you ever want to compare more than 2? Because you know what you're doing, right? Okay, anyway, that's not my opinion on data science, but okay, that's okay if they believe it that way. So now we can at least have multiple next to each other. So let's go and run some more. I have an interesting Python script here. So I can open up the command prompt from here and say Python run. Oops, that's not there. Why not? Oh, sorry, run.py, of course. So what this will do is we'll just use different regularization rates and run the model over and over and over again. So as you can see in the top right here is that the first run has started. The second one will be coming it's not there yet. Second one will be coming any second now. So this is how you can run multiple runs right after each other with different parameters, and also the graph should update. Now let's clean up a little because, well, we don't want to have a lot of crazy stuff in here. So let me get rid of the first 4 runs, archive them. So my graph should become clean any second. There we go. So 5, 6, 7, and 8 are starting. I would expect 9 to be there as well pretty soon, and maybe 10. I think it's 5. So this is an easy script because what it does, it just calls the same Python script I've just been showing, iris sklearn, with different parameters. So then you can change different settings of your model easily side by side, have it run on any environment, and compare. Okay, let's wait until this is finished. Come on. Just hoping for the graphs to update as well. This is the interesting point number 2, because this breaks a lot. Phew. So as you can see, we tried with different regularization rates over run 5 to 12, 5 to 13 even, and you can see the accuracy responding accordingly. So for experimentation, this is a very easy environment. Again, all of this has been logged on Azure, and can be seen in Azure as well, and can be restarted from there. If you're not into the graphical environment for starting jobs, we can also do that using code. So we can go, whoops, let me get the new command prompt, and say, hey, I want to go Azure account show. I might need to change the settings. Is that better? I think so. Okay. So Azure account show, I already configured my Azure account. I would assume, you know, if you do Azure login, Azure list show accounts, etc., you can set an account. You would know how to do that. That's not dependent on Azure ML Workbench. It's just general Azure CLI commands. So at least I'm connected to my account, and I can say, hey, I would like to run an experiment, and I would like to run in a local environment, and the tool I want to run, this Python script I want to run is the sklearn.py. Go. It's essentially the same as doing it in UI. And with any luck, it should also pick that up in UI, and on the top right, just above my, my command screen, we should be seeing that now. Nope, we're not. Interesting. Another refresh then maybe? I found that the number of times you click refresh, that also introduces a bigger risk of this tool breaking down. So I'm trying to limit the number of times you click refresh here. So I'm not sure what happened. It should have run. But sorry? 14 is there? Oh yeah, it's there. Sorry. Yeah, you're right. Is that? Yeah, it's just what just happened. Yeah. Good. Thanks. So that is there, and of course, if you want to do the same thing for a different environment, you can do Docker, for example, Python, and then run, whoops, Python, then run the Iris sklearn as well. So now, at this point, so now I'm spinning up a Docker environment, doing the run. You can see it in the top right showing up. This would take a little longer because it's setting up Docker as well. But yeah, this should be done any second. So the next step would be to change from Docker Python or local to something like Azure ML. And that's where you run into the not implemented exception. So that won't work. So basically what we did, we ran the model, we traced that you ran the models with very different parameters in Azure, but we actually haven't run anything in Azure. We just have the logging in Azure to see what happened. But all the execution has happened here on my machine in Docker and local Python. And that's too bad because, well, the idea and the promise is to have it easily to say, hey, Azure, what is it again? Azure ML, experiment, submit, C, Azure ML, for example, and then my Iris sklearn. I won't execute this command because it won't work. That's still open for improvement. Let's call it a preview. So if you go to your Azure environment, let's see what's in there. So in Azure, you will have a lot of items from your experimentation going on. So we can see workspaces. Let me enlarge this as well. We can see my experimentation environment, and then the workspaces of every model that I created. So here's one. There's nothing much to see here because it's only a container, and there's no interface yet to show the runs in Azure, but it is logged, because if you use another IDE like PySpark or RStudio or whatever you would like, you can connect to this and see the runs. So they're logged here, but there's nothing really showing you that. And then let's imagine the machine learning model management would work. We can look at that as well very shortly. If you did your scoring, your training locally, you ran it, perfect, now you want to scale it out, that's where the model management tool is for. So the idea is you publish your model using a command line or using the UI in the workbench to publish it here and to make it out into a web service as Azure ML Studio did before. So let's see if this opens today. Thank you. So here's my model. The way you turn this into a web service is that you first need to run this script. So you have published your Python script, or no, it's not your Python script, it's the trained model from your Python script in a PKL format. As you can see here, models PKL. That's what you publish here, and then you can convert that into a Docker image, which will run that PKL and allow you to talk through it using a RESTful API. And then we can define a service on top of that to be able to actually call that. So we can click Create Service here. This is all well and good, because I can select the environment I want this to run in. I would say class, iris, TechDays, and maybe I want extra settings, and then click Create. And we will not wait, because this will break. It will set up the Docker environment all right, but the rest part of building a Azure ML web service on top of it, that's not there. So the promise to do this, fine, this is not done yet. This is really new stuff, so I would hope this will be resolved in the next couple of days. I've been in touch with the product group. They know, they told me this was not to be expected to work today. So good, at least it was not me. But I hope you get the understanding of where we're going to, right? We're trying to build a workbench. We have the workbench now that allows you to run, there you go, error. That allows you to run these models wherever you want to run them, locally, Docker, cloud. And you can see all the runs and manage them easily. And then the next step would be, once you have a model that you like, publish it as a web service into Azure. And that's, well, the biggest step there is the last step of converting it into a web service, and as you just seen, that's not there yet, but the vision is there to do that. So let's go back to my slides for a sec. We can skip that, that all happened. Thank you, demigods. It worked, woo. So, what do you need to pay for this, and how would you work with this? Well, we have an experimentation account, as I told you, that's per user. You can have multiple workspaces in there, so if you want to share one account per 2 users, the first 2 are free. You can have one account and have 50 workspaces, each its own. Why would you have multiple workspaces in one account? Because it makes it easier to share, for example, data wrangling files. So if you have one function to wrangle one file that everybody uses, you can easily share that using one central account and then having multiple workspaces in there. For the model management account, there's multiple tiers. For dev test is free. For production, that's still coming. The tools, the workbench, and the Visual Studio Code tools for AI are all free. So that's always there, regardless of how you use the other 2 services. Okay, so now we talked about what we did with the workbench and the experimentation service and model management service. Let's try and understand how this all fits together, because there's a lot of stuff from Microsoft in ML and AI. So what would you use when? So we came up with this, I like it, graph. It says, hey, if you want to build your own or consume, that's the first choice. If you just want to consume some AI model or ML model, please have a look at the cognitive services. There have been multiple sessions about that here on TechDays to use those. So you don't need to program and train and score your own models. You just use our models for example, face recognition, but also churn analysis, recommendation engines, etc. Build your own. Then you go to what we call Azure Machine Learning. That's not the same as Azure Machine Learning Studio. It's just the umbrella term for what we offer. And then we have multiple items here. So if you like visual tooling first, then you will use the good old Azure ML Studio. If you like code first, more flexibility, more freedom of choice in where it runs and what frameworks you'll be using, you have 2 choices. You can either use our machine learning server, which also runs partly in SQL, which is on-prem or in a VM in Azure. There you can choose, for example, to run it in SQL Server, as I just mentioned, or on-premises Hadoop. Fine. If you want to use the cloud and the Azure ML services like the Experimentation Service and the Model Management Server, then you go the other direction, and then you have a lot of choice where you want this to be finally ran. SQL Server, Spark, Hadoop on Azure, Azure Batch coming, Data Science VM, and the Azure Container Service. Again, I've been showing you a lot of these tools, except for the last part here. That didn't work. Deployment of the service to Azure. So I hope this kind of makes sense on how we visualize where you would go depending on what you would need. Right? Visually, Azure ML Studio, just consume whatever we made, go to cognitive services, build your own and code it. You can have the choice to do it on-prem or in the cloud with different options. Okay, so where can I learn more? Well, in summary, we talked about the new services, the Experimentation Service and Model Management Service. We talked about the new tools that we introduced, the Visual Studio Code tools for AI and the machine learning workbench. We spent most of the time there to see that. What's next? Try it, and please tell us what you think. There's a link here, the aka.ms/aml_deep_dive, which will show you in a nutshell whatever I've been talking about, with links to where you can get more videos and more tutorials. Our roadmap, so where we'll be going with this, is obviously we're going to add Azure Batch AI support. Azure Batch AI support is a tool that will, Azure Batch AI is a tool that allows you to run massive scale of parallel AI processes. So you can just say, hey, I have this pool of 50 servers, run this tool, run this AI process for me, and have it configured that way, much like Azure Batch, but then specifically for AI with different frameworks. We're rolling out to more regions. We're now in West US, East US, and Australia, I think, for some reason. Tell us where. And obviously I know where I want it to be deployed, but I need your help as well to tell us that, tell the product group that it really, really, really should come to Western Europe very soon. We're moving towards GA. We're trying to iron out the bugs, and using that link, you can also give us and tell us what we should have been doing and where we need to improve. So with that, I hope this was enlightening for you, and I hope to see a lot of cool stuff and a lot of good questions and feedback on the tool. Thanks.